Hello.
Hello, everybody. This is the final report of the today's Geo AI Camp.
So we work hardly from yesterday and discuss new ideas, new concept, how improve Geo AI. Big part was focused on how to use and improve Jackdaw, but we also spoke about Allianz effort, about the climatic and weather data, and now we will make short summary about the presentation. I think that I will ask the people who work on this to come and tell a little. Aaron, please, first is your come here.
Okay, so basically the idea is that a lot of knowledge can be embedded in different files, and it would be beneficial for Jackdaw to have access to those files. And mostly inputs are PDFs, but also maybe other formats. It really depends on the type of data that we are working with, maybe .ax, maybe PowerPoint slides, but I think that PDFs is the most standardized formats to have policies embedded in those files. And there are several challenges about the whole process. First of all, policies can be local. So when we talk about embeddings, they are mostly done for given language. So if we have, for example, embedding model made for English, it will not work for Polish or for Czech, but there are already several existing embedding models that should work for multiple languages, so that's a good thing, but of course we would need to test that because the main idea is to make it work for English language and then expand it to the other languages. Also, results returned by the pipeline may be not optimal, so they need to be optimized then by deploying a re-ranking method. The ranking method is basically evaluating the provided scores and provided text and deciding which text fits the user question the best. So doing that, we can improve the overall results. Also, there's problem with chunking length because when we run chunking, so just splitting the documents into parts, we can do it by fixed length. So every chunk is the same length, or we can do semantic chunking, but doing the second option, of course, the results are going to be better because chunks are similar in subject. But the problem is that we cannot control the size of the chunk. So it really depends on how many chunks we are passing to the final model, to the Jackdaw to process. And this is, of course, need to be decided. And the last challenge that was recognized is cleaning the text after parsing, because, of course, PDFs can contain multiple artifacts. Something like multiple dots, and those artifacts need to be removed, and it could be done by some rule-based methods. So, example, if you have two dots next to each other, remove additional dots and only one dot remain. But we need to think about all possibilities in this case, so all rules basically. So other option is to employ LLM to process the text and return text without those artifacts. The problem is that, of course, LLM can hallucinate, so of course there's some challenges. And the whole process, maybe this slide should be before. describing the challenges is that we have our PDFs, which are parsed to the text or Markdown or JSON. It's also need to be decided which format is the best for us. Then we deploy chunking, so just splitting the text into smaller fragments. And then we embed the chunks into vectors and use those vectors to populate vector database, in this example, Chroma database. And as the result, we have data source for Jack.access and two benefits: improved knowledge, because the baseline LLM cannot know everything. So this is the source of knowledge. And also, doing that, we can decrease chance for hallucination of the LLM. And basically, that's it.
Okay, thank you.
Yep.
So the next issue is interpretation of OGC WMS services. People who are dealing with GIS know that this is most often used service for publishing of geospatial data, but unfortunately, this service is not very friendly for machine interpretation. So I would like to ask Dima or Matusz, who will explain what is the idea, how to work.
So me and Matusz, we were working on this task, and basically we're integrating this into GeoTools that Matusz is developing and then integrating into Jackdaw. Yes, the WMS services, they're like very popular. They're like created by usually public authorities who publish big data sets, because like if you look overall, probably the most spread geodata is JSONs that are published by some like private entities. But if we speak about public entities, definitely WMS is the most common format to share this data. Because before we were like integrating the services into GeoTool, and we were defining each WMS endpoint separately. We're like describing it manually. So we have decided to do some work to automate the process of integrating such data into GeoAI tool. So first step, we set up some metadata catalog, which is working on CSW standards, which is catalog service for the web. It's developed by, as a standard, is developed by OGC. Basically, there are like several requests there, but the one that we need initially is get records, which basically returns all data sets, meta information about all data sets that we have there, because user, like he can ask about the weather, he can ask about land use, he can ask about land cover. So all this information is there, and it's some important elements there, like the name, abstract, geographical extent, data quality, some like hierarchy of data sets in which this data set is. So this helps then the GeoAI tool to select appropriate data set for analysis based on user prompt. Then another thing what we had difficulty with before is to provide styles for different classes to GeoAI tool. So we have decided now to use get style request from WMS service to get SLD styles, because basically all WMS services that are published, they have this ability to automatically generate information about classes in form of SLD. SLD, for you to imagine, is something like XML document which has information about the name of the class, which color is used to visualize it in the map. So this we use, and then to basically to put it all together, we create some graph with semantic entities from different registries from, for example, Inspire registries. For example, if you take land use, it's Hilux value objects, and like for you to imagine, it's let's say primary sector of economy, and it's translated to all European languages, and it describes exactly what it is, and it gives the code value in the data set. And then it's some big, basically semantic data that we can integrate, Wikidata, OpenStreetMap. Then we interconnect all those. This work, it can be somehow done automatically, because in all this semantic data, it is sometimes for the most popular entries, it's interconnection, let's say. So it says like wiki object with the code Q515, let's say it's the same as OpenStreetMap object with relation, which is code like, let's say, 435 and so on. There are like also some like small practical stuff that needs to be done, because when we call WMS service, it's, I think, better to use images in the scale for which this data is meant. So if we work, let's say, for cadastral data, to use scale 1 to 5,000 and so on. So it needs to be some functions that calculate the desired image size by the scale which we need. Then another thing, small practical thing, is to create a function for raster data that creates mask on the geographical area of interest of a user. It can be like statistical unit we plan to integrate, the whole hierarchy from NUTS, then places like cities, villages, natural parks. And another thing is that now for each WMS data source, analysis tool for AI, it's done separately, but there are very many tasks where some general calculations could help. Let's say user can ask what is the proportion of forest in the area, what is the proportion of water in the area. Let's say if you take the forest, what amount is coniferous tree and leafed trees. So this we want to put together into one tool that will be able to do these tasks. So like if we speak systematically, the inputs are new inputs that we create here is CSW catalog with metadata. Then let's say instance of map server that creates WMS services. And then various semantic information that is puts it all together. The challenges we face is to basically to get and preprocess, to write functions to preprocess and get the data from CSW catalog. Then we also need to create graphs of these semantic entities, and we need to connect with it styles by the name of the classes, and then program this generic tool to process the WMS data. So if we look together, maybe here, what we come to is that we integrate CSW catalog, semantic data, SLD styles. Those are like interconnected new inputs into the GI tool, and then we develop new tool to analyze basically WMS data. And like in future, after we're done with it, it's possible to include, let's say, more complex analysis, because in CSW catalog, typically it's also information where to download vector data. So for some analysis, let's say raster data from WMS is not enough, so it needs new tools would need to be developed. So this is for me and for Mateusz. Probably I've said everything, yeah. So thank you.
Okay, thank you, Dima. There were many times mentioned the word of metadata, And the next challenge was focus on the metadata, how metadata can be improved and how metadata can be included into the system. So I will ask Raul if you can come and explain.
Wait, actually, can I reload this? Because I think that this is not having, okay, yeah. How to present here? So,
Zobrazit. Display.
oh, yeah, okay. Yeah, okay. So basically, this working group was basically a specific use case of the metadata here. The main goal here for this was to define some way to describe some data sources that can be used for the analysis of data that can be got by Jackdaw, basically, and then presented to the user based on different types of queries. So at the moment, if you remember, Karel showed us yesterday about the Jackdaw system. It has already different data sources connected, but these are kind of pre-wired data sources. So Jackdaw knows, for example, that data source A has information about points of interest, and in points of interest data source, he has information about buildings, restaurants, etc. So he knows how to access and where is it. And this other data source has other types of information and so on. So the idea here is how we can try to generalize this so that, and we can add more data sources to Jackdaw in the future in a more generic way, right? So kind of Jackdaw make it more automatic, the interpretation of the different data sources, of course, with the help of LLMs as well. So obviously we have many different existing metadata standards. We know that we have DCAT and extensions like GeoDCAT, quality extension. We have also Stack, which is very important for our purposes in different projects, OGC, records, ISO compliant, and so on. And there are already many different alignments between all of them, like OGC records aligned with ISO. Stack is also aligned with OGC records. And we have also made in another project's alignment between DCAT and Stack. So this is some work that we are now implementing the specification of this so that you can easily move between one standard to the other. And apart from that, there are some tools that have been developed. We were also finally able to discuss with the Czechs from Prague as well, the tools that they develop using LLMs that, different tools which have specific data sources and use, of course, some parameters to query these data sources, in particularly, for example, the bounding box, the area of interest that we are interested. And some of these parameters are also generated by LLMs. So there are many different tools that are connected to these or not. Like, for example, you have like semantic triple store that we have been using in many different projects, which is from Fruity, that also can be connected to the work that Dima was talking in the previous, because has information about the spoils and all this semantic information, but also LPS data from many different places in Europe, and Eurostat data, FADN data, and so on, soil data, etc. So there are many different types of data sources available there. And Jackdaw already uses the semantic triple store as well for SPOIS. But there are other sources that are integrated into the LLM from the Czech colleagues, like, for example, map servers for the processing of raster images from WMS services. In this case, in particular, they have land use and land cover from Europe. They have also another SPOI endpoint, which is more related to WFS type of endpoint. They have also connected endpoints for weather data. So coming from map server, a particular map server, or from the OpenMeteo API. So these are already things that we can connect and reuse. So here, of course, the challenges is first to access the right data. So that's the main goal here, how we can access the right data to Jackdaw to answer to the questions from the users. So we need first to agree on what are the basic metadata that Jackdaw needs to select a data source and or a data set in a data source. For example, simple things that we came up that we know we will be also be able to leverage the power of LLMs is things like the title, description, spatial information, temporal coverage, and of course also some access information. So how to, for example, if this is a data source, how to filter, how to access this data source, and so on. Obviously, there can be additional metadata that can be very beneficial in answering queries. For example, we were thinking about the observable properties that are associated to a particular data set, quality information, and that kind of thing that can improve the quality of the responses that the LLMs can provide back to the user. And then, of course, we need to select the relevant tools and the mappings to datasets type to be able to process or access those datasets, right? So that's more or less the discussion that we have also with colleagues from the Czech. So what will be the process here is that, well, Jackdaw needs to have access to the metadata from these different data sources. So we can add individual data sets, maybe. That's something that we need to see if it's actually relevant. For example, there will be some button in Jackdaw that say, okay, I am a provider of this data set and I want to make it accessible via Jackdaw. So he just need to fill in some basic information and provide it to Jackdaw. But most generally, we will probably try to leverage existing catalogs, registries that includes many data sets, right? So that's where the tricky things come into play because, well, basically on the one hand, we need to have metadata about the catalog and how to query, and we can maybe use LLMs to generate queries to filter the catalog to get only the relevant data sets. And once we have these relevant data sets, we can have like a next step, which is actually from the potential relevant data sets to get the data that is relevant to answer the question of the user based on the metadata of the data set itself. So basically, this is the two steps that we are trying to identify. On the one hand, discovering or selecting the data sources and then selecting data sets from these data sources that are relevant to answer the query. And then, of course, later on, we need to access the data, of course. Ideally, of course, we need to use some relevant tools here. So probably that means some use of standardized formats like, things that are accessible via WMS or things that are accessible, I don't know, maybe CSV. I don't know. We need to identify what are the potential tools that can be relevant for our purposes. And we were working on creating some examples of metadata describing data sets that our colleagues here, my colleague Aaron will now take it as an input for providing some simple examples how LLMs can be used to select all of between different sources based on this metadata and then get to the next step, which is access the data. So here, well, we need to provide some examples, carry out some experiments, and try to see the connections points between the work from our colleagues from Prague, Matusz, and our colleagues there, and the work that we are doing at PSNC. That's on my side.
Okay. Thank you. There is no presentation for next challenge, but maybe that I will a little conclude what was yesterday discussed and also what was presented. So the Atlas of the best practices as per is describing some regional data with big details. So we discuss if Jackdaw can benefit from this, but on the other side, the main result was that probably it could be on opposite side that the Atlas of best practices can use Jackdaw as some source of information and integrate more data because there are some other components like Vultr and other with inside of the Jackdaw, and that probably, for example, we can use this for scraping processing of regional data and put much better regional information into this atlas. So this is this. And next last things related with the Jackdaw is about LPS data. Probably I will again ask Dimayes to make some things.
Yeah, it's me again. So I haven't been part of this team, but I have heard what they were doing, and maybe can tell you something about it. So basically, LPS is like a system of field blocks in Czech Republic used for farming. Before it used to be that it was stored information just about field blocks, so it meaning that it basically could be several fields with different cultures grown belonging to the same farmer. But now they also publish information about separate fields with cultures grown on separate fields. But unfortunately, there's two versions, one with basically with field blocks and another with separate fields and cultures. They're not like published in the same data sets. Those are like two separate data sets. One published in XML format containing all information about economic entities that operates on the field, about let's say some geomorphological data, what is the area, what is minimum, maximum altitude, what is the slope on the field maximum, and so on. And another it is of value for us because it has more precise geometry for all fields and culture like agriculture that is grown there. So for you to imagine, here is some map, and with red you can see the field blocks, and with color you can see separate fields with cultures grown there. So for example, here it is sort of like big field block, and it has 1, 2, 3, 4, 5 fields with different cultures grown. But it's actually like funny here. I noticed that there are like some fields in Czech Republic where sweet potato is grown. So it's like potato. Okay, I didn't know that in Czech Republic on some fields they grow potatoes. So let's say so here the interconnection is not so difficult because probably this identifier of LPS block in this field, so it can be like easily connected. And we were thinking how to use this data in relation to tourism, because some people can go to Jackdaw and ask about, let's say, traveling to some countryside for agrotourism, and so we were like thinking, it's not related. Yeah, so we were like thinking to think what is just a second. We were like thinking what attributes from these two interconnected data sets we could get to derive some attractivity of those regions. Let's say what came into mind that usually like small fields with more forests in between. They're like more attractive for tourism. Also, let's say if you analyze cultures, usually like big field with potato, it's not so like interesting for tourism. But let's say if someone is growing lavender or like let's say sweet potato, it can be like interesting for people who are traveling. So we're like going to interconnect these two data sets and see which attributes that are contained there could be of interest. Also, these XML files, they have information about the company that owns the fields. So it's possible to check registry of enterprises and see if, let's say, this farm is producing something, has a shop. So in theory, it also can be interesting for agrotourism because, of course, it is more interesting to go somewhere where you can have, let's say, a local store with milk products on the farm, or like some local store where you can buy some products from apples, like apple wine or like apple juice and so on. And then another thing what we need to do is to think then how to feed this data into Kafka, like Jackdaw, to use for queries there. Thank you.
Okay. Okay, I think that it was the last presentation which was related to the Jackdaw activities. And before we will move to other things and other points, I would like to also make some conclusion about the topic, what was discussed here and what in some way define us strategy for next future. Because what is important? Important is to bring the Jackdaw very fast to the people, but of course we have also some could be long-term goals how to make this more and more clever and how to automatize most of processes. So what we discuss with our colleague from Slovakia, but also with other, that probably from the beginning will be good to start with could be a limited amount of the data and target implementation. Yes, for example, to prepare implementation which will cover some problem and will be feed with some limited set of the data, not for any type of the people, but for example, to prepare something for planners or to prepare something for agriculture with in reality with functionality which is now, because this is very important to be able to come very soon and very fast to the market to have success. And many things which we discuss here to include it automatic discovery of the data, automatic services has to be our long-term vision where we have to work, but we need at the beginning to start with something, not to trying to cover any type of the solution, but of course we would like to do this more and more generic, but we discuss a number of cases where probably could be make some local implementation very soon, and on the next phase to start to thinking how to do this. What also is some advantage that we made here more project, because Jackdaw principally started from Polyrural Plus, but there are other projects which could already benefit from the Jackdaw, and we have to start it and included some solution which are described into this project and use much more resources to improve the solution. So this is the way. And other important topic is to provide some assessment of different large language model or language model, because could be that in some cases will be better to use not something so big, but to use some model which will run locally. Because for example, if we would like to implement this as some could be internal analysis for some big customer, they will not agree to share their data with ChatGPT. They would like to use something running locally. So it is important now to make some benchmarking of different models which we can run locally. We discuss the possibility, and generally we will be happy to find some number of testers that we agreed with the colleagues that they will prepare some installation with different language models, and also that we will need to ask the people to put the queries, and we will analyze what type of the queries are using the different type of the people, and we can on the top of this use the right things. Of course, we were also influenced here with message which came to outside yesterday, that there is a new language model which was published yesterday by Chinese, and we also start to thinking that we have to look minimally on this, if it is really as is written in the newspaper or not, and if it could be benefit mainly due to the fact that it can run also locally, and they told that they use much less resources than others. So this is also some question, of course, to look on different models and to make some selection. So I think that it is generally all about JEGDO, we have now some clear vision for Polyrural and other projects. The Polyrural will run 2 years, and I hope that we will be now able to, with the pilot, to start prepare some target installation for different pilots with the relevant data, and but also we are thinking how to run and test this in other things. So now we will move to other things. Probably Alex, you will speak about this focal approach.
All right. So, climatic data super resolution. In a simple language, I know most of you understand the reason behind it, but in a simple language, imagine in the hospital, average body temperature is 36.6, but half of the patient have fever and half is dead. Right? Seems good, but it's not. Right? The same stands behind climatic data. We get weather forecast for Prague, but we don't get weather forecast at Kulaťák, where like some effects may cause, let's say, frost or overheating. Yeah. So for some cases, it's very important, and we'll talk about it later. For example, we discussed today a lot about frost prediction because it can be really a local frost within the resolution of let's say hundreds of meters or tens of meters, but we'll never get this sort of prediction unless we have weather station or we have a good model to predict hyperlocal weather. Right? It doesn't have to be temperature. In most cases, it's temperature, but it can be also wind. It can be also moisture, and so on and so forth. For such task, we need and we use a diverse source of data. First of all, we use climate models, that mainly used for, let's say, classical weather forecasting. And we leverage satellite data a lot. And in this case, we have to think about climatic data super resolution, kind of like in two axes. So first axis is temporal resolution, right? So let's say we have a temperature drop that lasts for hours, right? But we don't have so precise weather forecast. Second axis is spatial resolution, which is like more kind of logical. You have, let's say, Prague, and we have, I don't know, Kulaťák. We have some small part of Prague that can be the frost can appear there. For more reliable data, of course, we have meteor stations that are really local. They're like point data. Then it's very important to use topographic data because, for example, we have Thousand Slope or Northern Slope. We have to use also topography around this space, right? So, for example, we can have a pond nearby. We can have a forest nearby that may affect the climate drastically at a certain point. Of course, we use global forecast and so some sort of sensor data, as we discussed today many times, like some sensors on trees and so on. So I think it didn't update, but the biggest challenge actually is to get high quality validation data, because nearly every forecast we have is more or less global. Is not hyper local. It can be local, but it's not hyper local. It's not like resolution of tens of meters. So the biggest challenge is to get validation. So high quality validation means from weather stations, from sensors, and so on. To train our models, we need enough data. Yeah, so we are in machine learning, so we want data. We want high quality, reliable data. Also, big challenge in this case, since we know that super resolution is not new. Yeah, so it used a lot in videos and images and photos and so on and so forth. But the thing is, super resolution of, let's say, any sort of weather events may be very different from image super resolution. Yeah, because it's different processes. The dynamics of the weather is governed by different physics. And in a best case, if we're lucky, we can hope that our models learns correct dynamics of the processes. Otherwise, there are ways how to incorporate this sort of dynamics, how to find out what kind of dynamics the system has and incorporate these dynamics inside the system. But even though if we are lucky and we get reliable model that works well in Central Europe, there's no guarantee that it will work the same way outside of Central Europe, right? Because, for example, if we're talking about precipitation, that we know for sure that the nature, let's say the thermodynamics of precipitation here is different from thermodynamics of precipitation near the equator, right? And we have to be prepared for this. So this is also a challenge, but we have tools, we have knowledge how to deal with it. We did some tests on spatial temporal data in a way that we have data from weather stations, nearly 200 of them. And as I mentioned, the biggest challenge is to get high quality validation data. So far, we are able to take out the station from our training data and then predict parameters. For example, this is temperature, but we can also predict soil moisture and wind speed and so on and so forth. So predict at the point where the station is, right? And then validate the data from the station, which is very good. Yes, it's very precise. What we have is really good. But from this arises calls to action. Yeah. So get more high quality data. High quality data, first of all, for validation, and also download data from various parts of Europe. Yeah, so ERA5, Landsat, and such. Also, try to think what could be potential users, or what could be potential providers of, for example, data from stations, right? So farmers or some people who want to have this mapping of climatic data super resolution. Yeah, so simple example. There's a farmer who has meteor stations, and with this super resolution model, he doesn't have to have so many of them. He can, he can have, let's say, a half of meteor stations he would buy. We could give him 10 times better resolution with, let's say, potential error of like half a degree, right? So it's can be very, very good. Applications can be for forest, gardens, orchards, farms, and whatnot. Okay, thank you very much.
Okay, So who will speak about Alliance Satellite Images Challenge?
Okay, so we've seen in yesterday's presentation about the use cases of the cloud removal. You may not have heard how it works. So we do it by basically predicting the next frame, which is always cloudless, based on a sequence of maybe cloudly, maybe cloudless recent frames. And the input we use for that are Sentinel-2, which is the optical satellite, and Sentinel-1, which is the radar satellite. And we already have a working prototype AI for this. So here you can see the second column is the cloudy image, the recent one. This is the target, what we want to predict. So always a cloudless image, and then our prediction. And what is also very useful for farmers and such, for agriculture, is the NDVI, the vegetation index, or other indexes. It doesn't have to be this one, which basically tells the health of the vegetation around this area. And the last column is a visualization of the error, so the higher brightness, or the more dark area is the better prediction. And the first column is the supplemental Sentinel-1 frame, which we use because it's not there are no clouds here, but it's hard to directly translate it to NDVI for. So what we discussed today is how to deploy the AI, collaborate with LESS project, and we talked about their Earth observation API for downloading the data. And there are a few challenges, such as storing the data and cutting out the relevant parts and transferring the data between components and such. Maybe you can help me talk about a bit about the front end.
Okay. Today, as Jiří said, we have discussed the deployment setup of the components, because so far the guys from Czech Technical University have used like the manual process to download and to access the data and to process the data. So we have been talking about the way how to automatize this, and actually we have been developing an API to automatically download satellite data and to automatically extract the areas of interest and calculate the vegetation indices for those areas. And actually we have started with like pilot implementation of the API to some front-end application for end users. We have used this Info4Agro application. You can see the screenshot from this application here, which aims to serve as some kind of advisory tool for farmers or agronomists. So we are actually trying to incorporate these AI tools for cloud removal to this application, and you can see on two screenshots here the pilot implementation of the data management workflow, which downloads the data automatically, serves the thumbnails of the downloaded data to the user, where the user can select this cloudy image and then send it to this pipeline to remove the clouds and replace it with the cloudless image. And here is just another screenshot which displays this management panel in the application, which allows the user to download the data simply by clicking on the button and compute any index. Okay, so that's what we have been working with other guys for those 2 days. Back
Thank
to
you. That's it.
Yes.
Is the next presentation, but Peter is not here. Alex is also not here. Oh, there you are. Okay. Um, so the hyper-local forecast, which we've already also talked about yesterday, we know it works, and we already have a working prototype and a solution. Here you can see the comparison between global models, so for example, GFS and our localized prediction, which is predicting weather for a very specific, like for example, weather station, so one place. And this is the prediction for 24 hours ahead. And this is the visualization of the mean absolute error. So lower is better. And so the challenge, I guess, is more about finding customers for this. Again, you can see. So one example is for orchards, which we've talked about today. Well, not me, but some ideas for future improvement. We can use like static data. So for example, topographic, like a topological height, or the soil type, which is what is grown on the field. And we've talked about some potential customers like for predicting weather in orchards, which is for basically to prevent the risk of freezing in the orchards. Yeah, and for example, how do we measure the how well are the trees are doing? So we probably can't use any sensors, so we can use maybe cameras for that. Yeah, so how do you use the measure data, do predictions, and interpolate it? Yeah, some domain-specific knowledge which has to be done for the specific use case. So we don't have any result for the orchard specifically yet, but we know it can be done. Yeah, and there's the summary which he talked about with the AgriFood Research Center. So what orchards can use it on, and what exactly you want to predict, and how to assess the results, and how do you want to deploy it. That's it for me.
Okay, so there were done all presentation from this 2 days work. I will try to make some small conclusion. As you saw, there were done a lot, but there were recognized that it is necessary much to do, yes, because it is important to be able to move forward with new technology, and it is important to be able to connect different institute, different organization to work effectively on develop new methods and tools which will help. What is good that we have now some additional projects where we are cooperating with other people, and we will be able to in some way combine resources, combine also computer capacity, because in some project now CESNET is part who is able to make some experimentation with large computing. Then we are able to do. There is more partner from Slovakia, from other countries who are ready. And our goal is to invite more and more people to work together to bring, could be Jackdaw into the bigger reality, and to come with our approach which is different from current could be large language models which are focused on uniform platform. Our idea is to go with a distributed solution with number of services which can vary, because we expected that it could help us to reduce necessary resources and to use the possibility to integrate the work of different people in different countries. And I think that our meeting, from my point of view, was good and successful. We had a number of very good discussion, not only about topics, but also about potential businesses, because business models are also important topics, and we have to thinking how to go. And I expect that it is not our last event, that we will be able to combine this projects to organize more and more things. In next 2 days, we will organize the event for Czech end users to explaining them how they can benefit from this new technology. And we will be happy to come to you, to meet you on other places. And we will be also happy if you will join our effort and will help us to extend it us already in September or October, beginning of October with Runar. We make the message, fly, Jackdaw, fly. Thank you very much.